So at this point, we're going to shift gears a little bit. Up until now, all of the presentations have been given by the scientists who did the work. And now the talks are going to be given by the commercialization managers or people from the partnerships office that are describing technologies that others have put together. And I have a feeling you're going to be able to tell the difference. So the hard questions, hopefully, we'll have scientists in the room to help field. Our next speaker is Alex Detrana, and he'll be speaking on real-time automobile weld quality inspection system.
Thank you, Mike. As Mike indicated, I certainly did not do any of the work associated with this, and my understanding is not at nearly as deep a level as the researchers who you've been hearing from to this point. Jian Chen is in the back of the room, and he's one of the primary sources of expertise on this technology that I'm going to be talking to you today, which is based on the need for rapid and automated weld inspection, primarily geared towards the automotive industry. So the technology that Jian and his colleagues have developed is both an apparatus and a copyrighted software that they came up with in a database for automatic resistance spot weld inspection. And he uses the combination of an IR camera and image recognition software to non-destructively and quickly evaluate weld quality. So the kind of welds that we're talking about are these type of resistance spot welds. And in a door opening like this, there are typically over 200 such welds. And evaluating each one is typically a manual, time-consuming, and labor-intensive process. This image on the right shows kind of a rudimentary setup that was used in development of this technology. It's got an IR camera here focused on the welds, and I'll get a little bit more into the details of it now. So as I mentioned, the current practice involves expensive teardown booths, so you've got to have a guy come and get the part off the line, go back to a lab somewhere, tear the welds apart, see how they did. They don't evaluate each unit. It's time-consuming and expensive, and it's a destructive process. Ultrasonic evaluation is another technique that's used periodically as well. It's not a destructive process, however, it still requires a guy to come and get the part off the line and go back to a lab and evaluate the welds, and that's time-consuming. So our new idea addresses all of these shortcomings. We can evaluate each weld. It doesn't adversely affect the welds or the parts. You don't have to take the parts off the assembly line, take them back to a lab or anything like that. And this schematic shows essentially how it works, where this plate represents the part that's being welded. These are the electrodes doing the welding. You've got an IR camera focused on the weld. The IR camera feeds information into the computer, which uses the database to give you basically a go or a no-go on each weld. Again, this is a unique technology that allows for rapid and non-destructive online characterization. It takes into account all the key parameters of the weld. So the IR camera is looking at the weld as it occurs. It can provide information on the heating and cooling rates, the thickness of the sheet involved, the material properties of that sheet, and the temperature characteristics of the weld. So things like the peak temperatures. Well, the peak temperature is pretty key because you don't want it to get too hot and burn through the metal. And the output is a numerical grading of weld quality. So that gives a technician who's operating a machine basically a yes or a no. If the number is above or below a certain threshold, then the technician will know whether to send it back through for additional welding, which presents an additional opportunity that you can have real-time correction in the event that there are defects, because it gives you an evaluation of the extent of the defects, possibly the nature of the defects, and you can correct those in real time. So as I mentioned, the automotive spot welding market is the market that the technology was developed for initially. Obviously, any sort of spot welding market would be applicable. And on a broader context, any weld that you can evaluate, any weld that has certain characteristics of a good weld versus certain characteristics of a bad weld, this could be extended into essentially any kind of joining technology with a little bit of development time and a little bit of money. Teardown booth and a pry test, ultrasonic evaluation are both the primary methods for evaluation. This is essentially what a pry test comprises. Both of those take time. Both of those take products off the line. So this is a completely new approach to weld evaluation. It eliminates the time-consuming and expensive manual processes. We've got a prototype system. System integration is underway at a manufacturing facility. These images here are what the IR camera sees and passes onto the computer versus what the actual weld nugget size looks like. So as you can see, there's good correlation between what the camera is seeing and what the weld actually looks like. This graph here shows the predicted weld thickness versus what the actual weld thickness was. So as you can see, we've got very good correlation between the model and reality. And this is one iteration of the graphical user interface that the researchers developed, that obviously it would be tailored to a specific type of application and a specific use, but it provides real-time information and real-time data on each weld as it occurs. So it's a little bit difficult to accurately characterize the market size because it depends on how you define that. So the automotive market is one huge number, but welding is a subset of that number. Taking that into account, the non-destructive evaluation equipment market was about $1.5 billion last year, and it's estimated to grow in the coming years. This shows who the various end users are within the NDE market. Obviously, power generation has grown significantly, and presumably automotive is covered within manufacturing. And this shows the breakdown of the NDE equipment market. So we suspect that this has the potential to be fairly disruptive within that market. And with that, I would be glad to entertain any questions, and if they get too difficult, then Gian will be glad to help me. Jeff.
Yeah, Alex, the integration of the IR camera, can that be installed to detect numerous welds, or does it have to be done for each individual?
It has to be installed such that it can see the weld as it's occurring. There's a kind of a corollary to this that's an offline evaluation that incorporates an IR camera and an IR heat lamp, so that you could do post-evaluation of welds, but this is focused on welds as they occur. So yes, you could look at multiple welds if multiple welds are occurring and you had multiple cameras. Does that answer it?
Is there any reason this could be adopted for human-operated systems as an aftermarket modification to any welder, or
I would imagine it would just be a matter of some engineering as to how to incorporate it into the into the system and account for motion variation and things like that.
Suppose you're looking at like a full penetration weld. How deep can it look? Do you need to look exterior, or do you need to look periodically as you're developing the weld?
John, did you hear the question?
I said, like if you're making
a full penetration weld, how deep can it look into the weld?
Oh, actually, this is resin spot welding, so the penetration, it's kind of there are different configuration of the welds. You can use the weld itself is made with 2 or 3 thin plates. Each plate is about 1 millimeter or 2 millimeter. So the total thickness of the 2 or 3 plates is about below 5 millimeter. So the weld is always kind of, as you said, it's full penetration. So basically, this technology can tell you or predict the weld, the size, which is right on the kind of interface of the weld, the filling surface. So it sees through the IR technology can only see the temperature or the IR intensity on the surface, but due to the algorithm of the thermography, we can calculate based on the heat transfer speed. We can calculate or predict the weld characteristics underneath the surface.
Okay, so you measure the thermal properties, and based on the thermal properties, you calculate what the expected quality of the weld is.
Thank you very much.
Sure.